All right. Mm, how should I start this? All right. So you want to know how to tell it with the angles? And let me see here.
How to calculate the angles.
It's um pretty much each shape has their own angles, and you'll see what I mean. So let's
Oh,
start with
okay.
let's start with this shape.
Okay.
Uh, MX3. So the name MX3. So in the formula, it would be, you know how to write it. Okay. How,
Right
how,
there, how does it know? How do we know if there's what
how
kind of
can you,
shape it is?
yeah, first, how can you tell it's if it's whatever it is? So,
Well,
so imagine someone gives us this molecule, right? Or this compound, or whatever. I forgot the name of the thing. I forgot the name. But they give you this, right? Um, and we just need to turn it into Lewis dot structures. So in skeletal form, it would be we have one M and three X's. And then we do what we normally do with the Lewis dot structure, just make the molecule. And boom. That's how it would look in the molecule shape. And in the page, I have it written as uh tri trigonal planar. Trigonal planar. That's the name of this shape. Now how now the next question is how do this looks like in 3D? Because that's how it looks like in Lewis dot structures. X on the side and X on the bottom. But now we have to turn this image into 3D. So see of it as now I'm gonna draw another one on this side and you will see. But I'm gonna draw it in a different view. So this is like I will say this is like a side view or top view or in what's that word for in anatomy? Superficial? Superior, I think. So basically you're looking at it from this angle.
Superior.
This is top and this is bottom. Okay. And you'll see what I mean because I'm gonna have to rewrite this. Let me use a different color. Now this is front view. Because now when I'm drawing the shape and you'll see what I mean. This is front view. You see it?
Yeah.
So this shape has angles of 120 degrees.
So how do I know? So it's like when MX3, it's always 120, the angle.
Yeah.
Okay.
So when you get this shape, the 3D image or the formula, like the structure, it's going to be the angles will be 120.
Or just divide 360 divided by 3.
Yep.
What you do?
You know, in the circles of the how can I explain it? The
If you
sphere of the whole thing is 360 all around.
Yeah,
But
so
you know you have
let me
three,
draw
you
it.
know,
So let me draw a different shape then.
Hi, guys.
Oh,
here's
all right.
Johnny.
Hey,
But
so
you know you have three connected together. So if you do 360 divided by 3, it gives you the angle of 120. So let's say for another example, 360 divided by 4 on a 4-dimensional angle, that's 90 degrees. So now you know you have about 90 degrees at 120.
Oh, got it. Thank you.
That's the most perfect circle I ever seen in my life.
ha, trying to see how would I would write this in here. Okay, so the X would be down here. Another X down here. No, that's too close. X here. And will be in the middle. And this X will be on top. So imagine they connect like this. And it's the angles anyways from like this shell with this shell and this shell. They give off the electron energy, and because they're repelling each other. Like that. Okay. So yeah, so this planar will always have angles of 120. If I give you this one, let me see, I need to pull up my sheet. Yes. Okay. How would that one look?
That'll be MX2, but the B stands for it's not a complete, it's not non-bond connected. So you will have a two dot portion. So two connected bonds with one non-connected bond.
All right, so how would we draw the structure? The 2D structure.
You want in a 2D structure?
Yes.
So M will be in the middle. And then the two x's.
Anywhere?
Yeah, let's do it in the bottom. Two x's on the bottom.
This also works.
And then a connected bond. Make it an homologue connected to the M. And then we'll make how can I say, two dots or dots on the opposite side. Or E. That's it.
We only need to put one E? Oh, yeah, it's MX2E.
And what shape does it make?
Trigonal?
I'll make up that.
Yep. This one is also a trigonal.
So it's also 120 angles.
Also 120 angles, correct. All right, so if I give you this one, MXE2.
One connected bond with two non-bond connections.
How do we write that?
So you could put the X on top portion superior of the M. And then two E's on the each side on the bottom portions. E and E. One connected bond to X.
And what shape does it make?
Still trigonal.
Correct.
What's your wallet?
Also angles of 120. So you got it, Imani?
Yes.
So those are the three kinds that are the same shape. Now, if I gave it to you a molecule, here's how it would look. A molecule with this. I have it here. Give me a second. Not this exact thing, but a molecule with this shape. So how do you write the structure for this one?
B in the middle. F, one F on both sides. And then, no, I mean, at the bottom. Yes, one F on the top. And you put the bound.
Mm-hmm.
And we're done. You're not done yet?
Well, the Lewis structures. The valence and everything.
Mm. Oh, okay.
Don't forget that. He might ask that in the test.
All right.
So that's how the structure will look inside here. And this would be considered MX3.
Mhm.
Wait, how, for the Lewis structure though, how did you know you already computed this?
How many valence does the B have?
Mm. B has 3.
How many valence does what is it? Fluorine has?
7.
Times 3. Equals
21, so it's 24.
24 divided by 2,
So 12 pairs.
12 pairs. Don't
Okay.
forget this.
No, I just didn't know you didn't write it out, so I was just making sure that it was, that's how we were doing it. So it's MX3 because
Each one is our element. Each one is the element. M is just always the middle.
okay.
And these are other elements as well. These are solid elements. This just means electrons, non-bond electrons.
Okay.
So I'll show you one with the non-bond electron. Let's see which one do I have here. Okay. 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 Here's one. I'm gonna do the MXE2. All right, so here's one.
Mm-hmm.
O2. How many valences O have?
6.
6 times 2, 12, divided by 2, 6. So we have 6 pairs to put down. So what will go in the middle? This is mx.
You only
What is it? We only have O.
O2.
So what is the M then?
Oh,
Mm.
you know what that means? O2. How many O's?
There's two O's.
2 O's. So let's put the pair.
That's an adventure.
1 pair done. 5 left. Let's complete the octet. 2, 3, 4, 5. Doesn't seem balanced. How do we fix it? Come on, guys. We just did this.
you got to make a double bond.
There you go.
And you're saying that so this is mx
E2. Mm-hmm.
mx e2.
Okay, so apparently the actual visual for this one is a triple bond. Why does it look smaller now? Starting to look bad, but this is the example that they gave me for MXE2. Because it's supposed to look like that. These are the electrons I'm talking about that are left over.
Well, isn't it the purpose of the E2 is the remaining electron that are not connected to the same bond?
Yeah, the 2 lines that are right here. I'm just gonna extend it over here. The 2 electrons. That's how it's supposed to look. You have two oxygens. They share a strong bond, and then there's two electrons in the end, extending out.
So is this another trigonal?
Mm-hmm.
Okay.
That's how it's supposed to look, even though our math doesn't connect, but I don't know why. 'Cause you got 2 for 6 here, and you got 8, 8. See, yeah, that's what I'm saying. It doesn't make sense because then you have 2 electrons left over on that side. But it's supposed to be 2 electrons on one.
Yeah, it doesn't make sense.
But I don't think on his review sheet doesn't say anything about it. So, but if he does put a formula like that, and that's how you connect it, you know.
That's confusing.
I know.
He hasn't sent anything, right? Mm. I'll be right back.
All right. Do you guys want another example, or do you guys want to move on to the next shape?
Can you do
The money, how you feel?
can you do MX2E or MXE2? Yeah, MXE2.
So you want to stay on the shape? Another one of this.
Yeah.
All right. Let me look for one because the one that showed me here is like, okay, so this is
You
what
know
MX
why? It's because when you ask for the shape, we say trigonal, yeah, but and the chart you send us, it's bent for the molecular shape.
All right, give me a second. Was it MXE2 that we're doing? Yeah, MXE2.
Now AX2E, MX2E.
Yeah, that's different.
Yeah, we
You want
did
to do
it,
that
but we
one?
said trigonal. Yes, please.
No, I was doing the other one. I was doing MXE2. You see, it
Okay,
says
but even that, the shape is linear, right?
the
The
shape is
molecular
linear. Yeah,
shape and the electron geometry is
I draw.
trigonal.
I have I put the 3D picture on the other one so you can see how it looks in 3D. Because it's very hard
Okay.
to draw those without the circle that I have right now. All right, so we can do that one. The MX2E. You want to do that one? X2E. MX2E, right? The example they have here is this SNCl. Cl2. The valence for SN is 4. CO is 7 times 2. Divided by 2, we got 9. Alright, so the SN would be in the middle. What do you have? Is that supposed to be bent? Okay. Chlorine's supposed to be here. 1, 2. Make the connection. So that's 2 so far. Bye. Maybe that's 7. Then we just complete the pairs. They do 1, 2, 3, 4, 5, 6, 7. Oh, I remember now. This one makes sense.
That's the subclass.
This one makes sense. I get it now. So this one there would be up here. That's why it's bent. Because of the 2 extra electrons that stayed over on by itself on this guy. That's X to E. So I'll write it here. In green. This is M. This is X. X. And the E. Do you see it?
Yeah, I see.
And then the angle on this one would be
Many.
120, yeah. And I'd rather draw it in a triangle so you guys can remember that it's a trigonal plane. That's why. It's supposed to look like a triangle. So the other one, MX2E, would be almost the same thing. It's just that it would have like another electron over here. Which I get it now because it was correct. I just that I was drawing it incorrect. All right, so move on to the next shape, or any questions?
I think you can move on.
Should I keep the circle? I think so. Right. I'm gonna jump. See if you guys can help me figure this one out. MX6. There's 2 angles for this one, Elmani.
Mm. M
That's
in the middle.
MX6.
MX6, yes. Their angles are 180. 1090.
Wow, I don't understand.
There's two 180s and there is 490s.
Hmm.
So let me draw this one. Actually, let me draw it in. Let me rewrite this in different colors so you can see what I'm talking about.
Why all of them not 90s? Maybe.
This MX6, isn't it all sides are 90s?
Supposed to be in the middle. How can I? All right. Does that make sense? It's tilted. So this whole thing is a plane. The section. Transverse. This is the transverse cut. Can you see it?
Yeah.
So where do we put the M?
In the middle.
Yep, always. Now where would we put all the other X's?
Where you have these colors meeting, like
All right, so the easy one, let's put the first four over here, right? All right, where the last two would go? Think 3D.
Top and bottom.
There you go. Let me connect it and you'll see it. So a molecule, this one would be, he gave what an example on his sheet, so I'm going to use that one. He put SF6. This shape is called what?
Is this the pyramid? Um, the trigonal bipyramidal?
Supposed to be kind of like that, but no. All right. Octahedral. Questions?
This becomes an octahedra instead of trigonometrical bipyramid.
I thought the octahedral all had 90-degree angles.
Because the trigonal bipyramid it's only a triangle base. This is a square base.
But on the book, the octahedral only has 90-degree angles.
Yeah, right here.
Oh, I thought you said this one has 90 and 180.
Yes, it does. The 180s are going around.
Oh, together, you mean?
Yes.
Oh, okay.
The 180 splits right there in the middle.
Got it.
The 90 splits the angles right there, top and bottom.
Got it.
Questions?
Can we do another one of MX6?
We can do its cousin.
What'd you say?
Its cousin.
His cousin?
Yeah.
Who's his cousin? MX6 sub E, whatever?
MX5E. MX5E. The molecule for this one they have is IF6. No, IF5. So let me get the bonds first. So that's 7 plus, okay, same thing, 7 times 5. 42, right? All right. Trying to do mental math right now.
Wait, what are you doing?
7 times 5 plus 7, that's 42, right?
Yes.
Okay, cool.
So
Okay.
21 pairs.
21 pairs. And, well, let me move this guy over to here. Damn. Okay. We have that one at the bottom. Okay, so let's connect the bonds. Mm, Put the bonds. 1, 2, 3, 4, 6, 7, 8, 9. Because this one's by itself. Here's the 16. There you go. That's MX5E. Do you want to see what I mean? I'll write the letters next to it. M, X, 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 and this last one was E. The last bond that didn't connect to nothing is E. The non-bonds. These don't get registered because they're complete in octet on each element. This is the only one that didn't get completed, so it stuck out with him. He still wasn't full. Questions? Does it make sense?
It's slowly coming together.
I just jumped from
Basically,
the third molecule to to the last design. I'm jumping around. I'm not going in order. Because the pattern repeats, it keeps repeating if you well, it keeps repeating. That's what I see. There's a pattern that keeps going on. You was gonna say, Henderson, sorry.
I get it. I wasn't gonna say nothing about it.
So MX5E has a brother. Oh, before I continue on, the design, the whole shape, the geometric shape is a octahedral. But this, the structure for the 2D structure, it's called a square pyramid.
Subclass of MX6.
Yes. That's why I said cousin. And same thing with the other one. I was about to mention MX, this one has a brother. His name is MX4E2. I just want to get to the complicated ones first. And the next one will all make sense. MX4E2. Another trick that I use, that how I know it's going to be a 6 anyway, if you give us just MX whatever this, like if you give us MX4E2 or MX5E, if he gives us these numbers, how do I know it's 6? Because I add the bottom numbers. 5 plus 1 equals 6. 4 plus 2 equals 6. In case if he gives us like, give me MX this, give me MX that. That's how I know it's going to be an MX6. So for this one here, the molecule they have is xenon fluoride. The name of this shape is square planar. This is a square pyramid because even though it gives it the octahedral shape, but it's a square pyramid by this sense, you'll see. Let's connect the bottom base. And let's connect the points to the top. The E will be alone, but when this is why it's called a square planar. These were the more important ones that come out. The other one was an octahedral on both ways because the whole shape showed because this bottom part here was not an electron, it was an element. It was the last F. So this is pretty much talking about like if you're taking a picture of it like the example he was giving, like if you take a picture of it, I forgot what machine, only these these 5 will show up, not the E. So that's why it's a square pyramid. Square bottom base pyramid. 4 sides. Front, back, left, right. So I'm going to do the other one, MX4E2. Any questions before I start?
No.
Let me know if it's confusing, because I feel like it is for you guys.
It's still a little confusing. But just keep going. I think as you go out, starting to catch it.
You have the sheet on you, right? Because you need
Yeah.
the sheet. That should be on the last part. Those are the pictures I'm trying to make. All right. So let me do the valence for this, and then I'll do that. 8. This 7. Divided by 2. 18. This one's supposed to look like that. Okay. So XE4. Let's put the molecule down. XE. There's only 4 Fs. All right, now let's complete the bonds. We already used 1, 2, 3, 4. So we're down to 14. And let's complete the bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The structure was really written like this. Okay, that's too tiny. Need more space. I'm just write it after. Oh yes, that's how it's supposed to look. And why is it a square planar? Because when it gets the picture printed, only this part shows up. These electrons don't matter. So think of it as MX error 2. There's 2 errors. MX5 error. The other one had 1 error in the bottom, but it came into that pyramid.
So the subclass here, you don't connect.
You don't connect the what do you mean you don't connect?
Like when you're drawing it out.
Like this?
Mm-hmm.
You draw it out, you make everything, but when the picture comes out, you only um go with all what the elements are. Electrons don't get included.
Okay.
Only where the elements are. I know trigonal trigonal planner was a bit confusing because that one included everything.
Right. Well, that's why I was asking how come, like, now I'm seeing that you're not including it in this one. That's what made me question it.
Well, that's the only thing it can make sense only because like when you're just taking a picture of it, it comes out like that. I don't know. I really don't know. That doesn't even help I never realized that till now. Like why are they different? Okay. I think where you got confused, so Johnny, with the trigonal planner, they do this, it works the same way with the trigonal planner. The only thing is that they don't call it the image, the geometry is trigonal planner, but one of them called is bent and the other one is linear. It still works the same way. It's just that they don't include it, so it would either be like bent, like
Mhm.
with right here. I'm just gonna use this side as an example. I don't want to draw the whole thing again. I'm just gonna take it. It's like either like right here, bent or linear.
Got it. Yeah, I'm like,
This thing will it makes the triangle. It makes the triangle, but it will only count as this linear.
got it.
Same thing like that. It makes the triangle, but it's only linear. Or it came out bent if it goes down this way. Sorry, too much like
It's okay.
if it goes like this. See? Then it became bent from here. So it works the same way. So think of like the E as an error. You don't show it, but it's there. So one is bent, one is linear, and the last one is trigonal if it's all three elements. Like right there. All right, so any questions before we go on to the next shape? No questions? That means we're all getting A's.
Yes.
Yay.
We're all
Hopefully.
getting A's if no one's got questions. That's amazing.
I need to keep watching it so I can
All right.
process and then ask questions.
As long as you got your list structure down pack, you can figure this out. This would be easier.
It's just based on
And
Lewis
he
dot
said he's
structure.
giving us the Lewis dot structures.
Yeah, but just in case, his mind might just be like, let me throw a little funny one there.
Curveball, like he did,
Yeah.
like.
Yeah, just figure out, do the Lewis dot structure. As soon as you got your Lewis dot structure and read what it says your MXs, and then from there you can just do the plot of.
All right, I got through the most complicated ones that I think was the trigonal and the octahedral. The next two is kind of easy. It just repeats. They look similar though. That's the one thing. So which one should we do first? Trigonal or tetrahedral?
Cathedral.
It don't matter.
They both have 4 each. All right, so give me a second, you guys, because I want to order some food. I'm hungry.
Okay.
It's really quick. It's just my neighbor. She's making food. All right, I'm back. Sorry. All right, so the next shape we're gonna do is, you said tetrahedral. That would be MX4. If someone would guess the angles for this one?
I think those are the 109 or something.
Mm-hmm.
109.5.
Okay. Yep. So that's the angles for this shape. MX4. So an element that he gave us as an example is CCl, calcium chloride. That's how you say it, I guess. And the other one was CH4. Okay. Let's do this one, CH4. All right, how many valence does C have? How many valence does C have?
Four.
All right, hydrogen.
One. So four.
This equals to
Eight.
8.
So 4 pairs.
Four pairs. Okay. Now, how would this look like in this circle? Anyone want to take a guess?
C would go in the middle. And then an H above, one below, and one on each side.
Hold on. I didn't think I would need this, but I kind of do. His example, I don't like his example. He uses a cube. And I don't like it. Gotcha. Okay, so let me see if I can draw that. See how- Okay, got it. So you said one on top and one bottom?
And then one on each side.
Or one on each side. That's the 2D version. This is how it will look in 2D. Correct. Now we just connect the bonds. The only
Yep.
4 pairs that we need.
Mm-hmm.
Now here's the tricky part. How the hell would this look like in 3D? And I'll draw it right now. Oh wait, no, there's none of that. That's a tetrahedral. Triangle base with 3 triangle sides forming a pyramid. So using a triangle pyramid as a base. Triangle base. Pyramid, I think, has a square base. This is actually the center of the whole pyramid, where the C is. So think of it as the center of the whole sphere. Can you see that? Can you see it? That's in the middle. That's like in the middle, floating.
Can we see what? Like, what'd
Like,
you
can
say?
you see? Can you see that? Can you see it in the 3D image?
Yes.
Okay. Because the C is it's suspended in the middle.
Mm-hmm.
So maybe if I think to help Henderson, do you get it? Do you see it?
Yes, I see it.
Okay, good. Almani, do you see it?
Yes, I see.
All right. Any questions? Or should I move on to the next to the error phases?
You can move on.
All right. So MX4, the shape is tetrahedral and the configuration is also tetrahedral because all the molecules on all four sides. So that was the example of CH4 that he put for MX4. All right, so now let's start messing with the subclasses. Let's start with this one. MX3E. So looking at this, what do you think the shape would be?
Will be a tetrahedron because 3 plus 1
That's the geometry, right?
will have a linear. A bent, sorry, a bent. The hedral pyramids.
That's the shape. Trigonal pyramid. It's going to be the geometric tetrahedral, but the shape of the molecule is going to be a trigonal pyramid. Example that I have here is pH3. Well, let's just find the valence and stuff.
Is is 5 plus 1, 3. Eight divided by 2, 4.
We're dealing with the magic number here. 4 pairs. Now, how would this look in here?
Each are all three sides, lateral, bilaterals, H's, inferior H. You can do that too.
Oh, you want it on the bottom? Okay.
No, it doesn't matter. It doesn't matter. No, let's keep H on top. Doesn't matter. Let's do the right thing. H on top, E at the bottom.
Here down here.
P in the middle.
No, I said E in the bottom, E in the middle.
The Lewis dot structure would be this. So complete the 4 pairs. You got 1, 2, 3, 4. And that's how it looks like in the 3D image. It makes the tetrahedral, but when it prints out, this comes out. So it's making the pyramid. The trigonal pyramid. Almost similar to the trigonal planar. But it's 3 of those planars on each side. 1, 2, 3. So that's why it's a trigonal pyramid. Any questions? No questions. Okay, moving on. Like I said, I better expect hundreds on this test. No one's asking me questions. All right. The next one for this guy. Anyone take a guess? What's the name on this one?
Trigonal planar. Planar.
This will be trigonal. Any other guesses?
I said trigonal planar. PLANAR.
Any other guess?
Couldn't it also be the trigonal by pyramidal?
Any other guess?
Mm. Tetrahedral?
Bent. Give me a second. Hello?
Yep.
This one is bent.
Ah. Why?
All right. So
Because two molecules are connected into our free flow.
that has to do with the polar. But an example for this one, what they have here is SeBr2. So this is the example that they have. SeBr2. So we don't need to do the valence and everything. We know that we're going to deal with 4 pairs. We're already there. But the structure would look like this. Destruction. That's how the Lewis dot structure will look. Now in here, it will look something like this. And when the image comes out, only this part is taken. That's why it's called bent. The polars on these electrons is pulling this guy this way, while these guys are pulling this way. That's what make it bent. But because they have a bond, they're connected. Does that make sense?
So you're saying that like polarization is
Yeah. This was making it bend.
gotcha.
H2O is the same thing.
So it's like tug of war
Mhm.
with
It's tug of war at the same time pushing because of the forces of these electrons with these electrons here.
but when you're using bent, do you still name the it's tetrahedral bent or is
If he asks you for the geometric, it's tetrahedral. If he's asking you for the molecular shape, it's bent.
gotcha. Okay.
So I'm gonna go over all of them, and then I'm gonna throw you some problems.
Okay, sounds good.
All right, so let me go for the next one. All right, the next person we're gonna deal with is this guy. Anyone want to take a guess what the last one would be?
MX3.
Yep. MXE3. And this one, what will be the shape?
Linear.
Linear.
Linear?
Yep.
Give me 1 second, guys.
So the shape for this one, the molecule they have for this one is Cl2. Cl2. The dot structure should be like this. Hold on, am I doing this correct? 714. 3, 4, 5, 6, 7. Yeah, that's correct. All right. So it doesn't matter which side you choose, it will look the same either way, I guess. So then in here, it would be like this. And that one makes it linear, but it's still a tetrahedral. Any questions?
No.
All right, before I move on to the next shape, let's recap. What are the bond angles for linear?
180.
What's the bond angle for octahedral?
Mm,
90 and 180.
And what's the angles for tetrahedral?
109.5,
And the trigonal planar?
120.
All right. And if I give you AX5E, what the molecular shape would be?
If you give what?
AX5E.
Trigonal by pyramid.
Nope.
You said AX5. Oh, E.
Yes, EX5E.
And what the molecular shapes? C star,
Yeah, what would be the molecular shape?
C star.
Square pyramid.
Square pyramid. You go into the part that we haven't even touched yet.
What?
Henderson,
All right, I'm gonna say shy.
we didn't even touch that yet. That's the last part we haven't even touched yet. And you're
I'm
giving me
gonna
the
say
answers
shy.
there. All right, so you again, Henderson.
I don't know.
What shape is MX3?
Trigonal planar.
Can you have a bent in the trigonal planar geometry?
Guys, I mean, can you have that?
Yeah. Can you have that?
Yes, you can.
All right. All right. And where would I find a trigonal pyramid?
What was the question?
Where would I find a trigonal pyramid?
X3E.
Where?
MX3E, you said?
Yes.
Yep. And what's the geometric shape for that?
Tetrahedral.
Tetrahedral. You with us, Siljani?
Yes.
Give me AX6.
Mm, give you what? The shape?
The shape and the geometry.
An octahedral,
There you go.
but isn't the geometry the same?
Yep.
Oh, okay.
That one is the same as both. All right, I'm gonna move on to the last one. MX5. Henderson's favorite. What are the bound angles?
Henderson.
I mean, I just tried to press the wrong button to unmute myself. You said, what are the bonding angle for MX5?
Yep.
There are 5 bonding. 5.
What are the angles?
Okay. So you have, I will start with the one in the middle. So let's say you have 90 and 120. Hello. Hello.
The professor
I heard
gave us
I heard it.
two.
Did you hear him?
Yeah, I heard
You
it.
can hear me?
Yeah, I can hear you. I'm
90
writing it
and
down.
120. Sorry that I'm so out of New York and I'm going in and out of service.
Oh shoot. Be safe.
Yes, of course. Partners driving. We gonna be okay. But 90 and 120.
But the professor gave us 3 numbers so we can actually see it better. The paper only says 120 and 90. So I'll
80.
show you the last one where it would
180.
be.
He always finds a way to confuse us.
180.
180 is always there because as soon as you pass MX2 or MX, any linear from that you will always have 180 involved.
Yeah, 180 is always there. We're dealing with a circle. If you cut a transverse in any way, sagittal or whatever, it's still a 180 cut.
But it will always be there.
It's always a 180 cut. So let's draw this one out. Let's see how. Wait, I have it here. Let me look at my thing. Okay. Okay, I see what they mean by the 180. Or the 120. Let me do that another way. I think I know how to do this for the 180. The 180 would be like this. Okay. Draw it this way. It's the 180. Oh, wait, no. No. That was supposed to be the 90. That's the 90. This is the 180. And this is the 120. I don't know if you guys can see that. Um, Let me write it this way. You guys will see. Does that help?
Yeah, throwing A and P at us.
I mean, it's the only way to help. If it helps you see
Hold on
the
a second, hold on.
cuts, if it helps you the cuts, then yeah. Do you see it, Elmani?
Not yet.
Not yet. See as the brown circle being cut down the middle from top to bottom.
Okay.
And the pink circle is being cut down the middle again from right to left.
Okay.
And the middle part is like the angles of each section in the middle circle.
Okay.
So if I can draw it like
Let's see it
this,
now.
from here to here is 120. From here to here is 120, and from here to here is 120. Okay. Those are the angles for 120. From this plane to this plane is also an angle of 120. So see if it's like if I cut this part from here, too many arrows. If I cut it from here and I go this way, let me use it better. Hold on. I'm cutting straight down here. Okay, but I'm gonna stop right here in the middle. All right, and then I'm gonna go out of the circle. That's like a slice, a piece of watermelon. So it will be like a chunk I just pulled off of a circle of a cake, a slice of cake. Does that help? Okay, so that's how those angles will be 120, 90, and 180. So let's use a molecule for this example. All right, I'm gonna use the one he gave us. PCl5. He did the math for everything. He said there's a total of 20 pairs. The dot structure would be P in the middle, 1 Cl here, 1 Cl here, 1 Cl here. Connect the bonds. And then just do the valence. So that's how the Duluth dot structure will look. Now how it will look in this pyramid. How it will look in here. That is the question. Anyone want to take a guess at it?
Isn't this one gonna be a octahedral?
Oh, I didn't write the name of this. The name of this one is called trigonal bipyramid. So how would we write this?
P in the middle.
P in the middle.
You will have 3 CLs as a tri, and then CL on top and CL on the bottom. And then you're connecting all sides to the P. Good.
What's the wrong color to use? And there you go. That's the trigonal bipyramid.
So is his expectation going to be for us to draw it, or he might
I-
give us
I
the
think you're gonna
drawing
have to
and
draw
have
it.
identify it?
I think you're gonna have to draw it and identify it.
Mm.
And
That's why I
also
drew-
gonna
that's
have
why-
to
that's why I
find the charges too.
No, not the charge. I don't think he's gonna find the charge.
He put the formal charges on the review sheet.
I mean, if you guys want to practice on the charges, we can.
I mean, but the charges is the same as,
That's we practiced before.
If you know how to do the charges, then yeah. Other than that, then we should practice it.
no, I think I'm good on that. I don't know about everybody else, but I think we went
Oh,
into,
don't worry, so
Um,
Johnny, you're not escaping math today.
huh?
You're not escaping math today. There's I want to touch on chapter 5 soon.
The laws, right? The gas laws?
Yes, I have some problems for us to practice.
Okay.
All right, so this is trigonal bipyramid. You guys see the two pyramids
Yep.
on the top and the bottom?
Mm-hmm. And the triangular base.
Funny thing, I'm practicing for art and I'm taking it next semester.
Oh, yeah. Well, tell them you can draw molecules and all these good things.
That's what I'm gonna be drawing in class. Actually, if they ask me to draw something, this is what did in chemistry, so this is all I know how to draw.
And then you'll be good. You will be good. You'll become a graphic designer.
What
You-
for
you
the
can
chemistry textbook?
create-
That'd be great.
Yeah.
All right. I don't know if you guys hear me eating. I'm sorry.
It's okay.
I'm trying to do
I
both.
don't hear it, but do what you got to do.
All right, so that's an element of MX5 with all 5 parts are included. And also, as I put it in my notes, there's no without non-bond electrons. So this is a non-bond electron structure. Does it make sense to everyone about these shapes?
Yes.
It's just the same thing as Lewis dot structures, just now we're just doing it in 3D.
Yeah,
Exactly.
it's making more sense now.
All right, so the next guy. Let's start doing with the E family. Always the odd ones. MX or E. Anyone want to guess the name on this one? It's in kids' playgrounds.
You said MX4E?
Yes.
Seesaw.
The seesaw.
That's a good way to remember it.
And you'll see why it's a seesaw. But I'm gonna draw it how to make it look like a seesaw, even though they don't have it here in the same way, but I can see the picture of why it's a seesaw. The example they gave us here is CE, right? Yeah, CeH4. Just letting you know, I'm not using ions. He might throw in an ion in there. That's why I said learn the structures because it also includes ions. I just haven't found formulas. I haven't found examples to do it with.
Got it.
But as long as you get you understand the concept of how to place the extra electrons, you'll be fine. All right, let me get this one then. SC, it's this one, it's 6 plus 4 equals 10, 2, 5. Oh boy, they're right there. So all we're dealing with is 5 pairs. How would I write this? Well, in the Lewis-Jock structures, this is how it would look. And because each hydrogen is only allowed one extra slot, but we have 2 extra, so they go here. That's the Lewis-Jock structure for this one. Now to look at it here, I said I wanted to draw the seesaw, so let me see. Hopefully I can make it. I can do it. I think I can. So put the SE here. 1H here, NH here, NH here, NH here. And this is the last bond that's right here. The shape for this one is this. They call it a seesaw because apparently these are, I guess these right here are the kids going up and down the seesaw. Horrible example, but yeah, that's it.
Yeah,
I don't know why they call it seesaw. It's supposed to look like a seesaw, but I don't see it.
I don't see it either. But whatever they say.
So imagine if I gave you an ion. Let's turn this into an ion. So it would be like what? SeH3 plus. How would that look? We're just playing with the numbers here. This is not real. So just let me do the quick math. Se6 plus what is it? 3 minus 1. Oh wait, I didn't want to do that. I want to do negative. Sorry. That. So to be plus 1 equals 6 plus 6 plus 3 plus 1 is 4. Me plus 10 equals 10, sorry. Divided by 2, we get the same number, 5 pairs. That's what I meant to do. So 5 pairs, same thing, will look like this. We have 1 extra pair, where it's gonna go here. And there you go. But this would be 3. But this is not a MX4E anymore. What is this?
An MX4E2.
No, it's not.
Oh, I don't know then.
Look how many X's are there.
Right.
3. So then it will be MX.
MX3E2.
Yes.
Yep. The shape of this one changes though. What letter do you see there?
T.
Yep. T shape. That's messing with ions. But it's the same concept, you see?
So for same thing when it was positive, you took away a electron. Negative, you're adding one.
Mm-hmm.
Okay.
No, but I'm saying it's the same concept. Like if he gave you this, SeH3 negative, just do the whole thing, get the pairs, and you can figure out what shape it is.
Yeah. I think I get it.
Okay, so if let's make this more negative now. Let's do this -2. But it wouldn't work. This one wouldn't work. Because
I
you
was
have
gonna
these.
say that gives you like a half.
Yes, we're dealing with 5 pairs and an extra electron. So this wouldn't work. So then let's erase that. That one doesn't work. But I do have an example for the next shape that we're going to do when we add another electron. When it's 3 electron pairs. Anyone want to guess the name? MX.
Say that again.
Anyone want to guess the name for the next, so the last one?
You did MX.
Look at the pattern. What's going down and what's going up?
MX2E3.
MX2E what?
E3.
Yep. And this one's everyone's favorite. Not really everyone's favorite, but the paper's favorite. Another linear. BRF2. Really? No. It is 21. But when you divide by 2, it comes out weird.
Mm-hmm.
Or my calculation is wrong. No, it's right. Okay.
Yeah, it's like 10 and a half.
I don't know what. Oh, I forgot one thing. The negative. I didn't see that. It's so tiny. So then we do a +1.
So it's 11 pairs.
Mm-hmm. I didn't see the negative sign. Yep. 11 pairs. So then we do the written molecule this way. PR. Bonds. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. Like that. Well, let me make it much neater. That's how it's supposed to, that's the Lewis dot structure. So I'm not done. Gotta do the brackets. There you go. That's the Lewis dot structure for this guy. BRF2.
I know the last one. And the other one is there too. The dark one.
So I'm gonna start you off. The BR goes in the middle. Where would the other go? Remember, it's a linear.
One would have to go to the left of VR and one to the right.
You mean one right here?
No. On the other one. Up one.
Here?
And then diagonal to that.
Here?
Mm-hmm.
And the other electrons go here. But how the image will come out, only these will show. Which makes it linear. So yeah, y'all need to practice to draw these. And that's all 5 of them. The linear, the trigonal planar, the tetrahedral, trigonal bipyramid, octahedral. That's it. There's only 6. Well, let me see. 1, 2, 3, 4, 5 shapes. So y'all ready to practice some? If I throw you a shape, you tell me what it is. Throw you an element.
Sure.
So where's the confidence?
After the practice, if we're getting them right, we'll be more confident.
All right, I'm gonna start you with an easy one then. Something very easy, very easy. Y'all ready for the easy one? Yeah, better not get this wrong.
Yes.
What would be the molecular shape and the geometric shape and the angles for this guy?
That's it? This guy? H2?
Yes, yes. As how easy as I can put it for you guys.
So
Those are linear.
two H's connect, bonded, and yeah, it would be linear.
All right, linear for
A
what?
180 angle
Linear for what? For the shape or the geometric shape?
Linear.
would be the shape
Just the shape? All right,
and
what
the geometry.
and the geometry. And the angle?
180.
180. Good. You know how level 1 is. It's gotta be easy.
Oh, I think we lost Imani.
Oh, I hope she comes back. All right, next question. Oh, and last one. What MX would be? Would that one be?
Would be MX1. I don't know.
Can be MX1 because we have 2 hydrogens.
So then what would it be? I mean, you're correct, so Johnny, but you wouldn't call it MX1.
You would just put MX.
MX.
So if I were to put MX1 on a test, he'd probably mark it wrong, right?
Yep.
Of
I
course.
mean, you can read it as MX1, understand it as MX1, but when you put it down, it's just MX. All right, you ready for the next one?
Go for it.
Level 2. This guy.
So this, you want the shape, I
The
would
shape,
say
the geometry, the angle,
trigonal,
and what kind of MX would be.
trigonal plantar.
It'll be a linear
Linear.
with a linear molecular shape with the bond angle of 180.
And what would be the name for the MX?
It'll be
MX2.
MX2.
MX2. How'd you get trigonal, Johnny?
I realized what I did. Well, not because you're bonding the C with the O, one on each side, so it is linear. I don't know why I said trigonal.
All right. And last easy level 1 question. From there on, it just repeats. So I'm going to be throwing you numbers that we already been through, and I want you to get it. But this will be the last easy one, okay?
Mm-hmm.
What would be this one? CN negative.
Linear as well.
Why is that?
We're only bonding C to N. There's only one bond,
All right. What will be the MX?
just MX.
Ah, you're missing something.
So that negative has something to do with this. The bracket?
So what?
E.
Bracket?
E. Someone did the structure.
Because the negative we lost an electron?
No. Let's do
No,
the
why?
structure, so Johnny.
I don't know. I'm guessing here.
Yes, I know. I thought you did the thing.
I didn't do the structure.
Let's do the structure. What many valence does C have?
C is 4.
Okay. N?
C is 4. N is 5.
All right, we're doing negative, so that means we what? Adding one
Add
more electron.
1
And the total will be
times. So
by
it's 5 pairs.
5. All right, so let's do the structure, obviously, only C and N. Create the bond. And then we do the valence. Okay, that's 1, 2, 3, 4, and 5. But to be more precise, it's actually this. Because it's a valence. I left it as valence so you can see that it only works, you get an extra E when you have a valence electron.
Mm,
So the structure will be E bonded with C, bonded with N. Print only that.
So it's MXE for shape.
MXE for this one.
So for MXE, that's it. We don't assign anything else.
Yeah.
Okay.
For this one, it will be MXE because that's how it will look. You have one extra E. It's like the MX, which we have, which was H2, H and H. They look the same. It's just that this one has an E.
Got it. Okay.
And like, imagine this. Imagine there's an invisible E over here. But
Mhm.
they only care about this.
Okay.
That's why E, that's why I say think of E as an error. This is just an error here. You see the ones with the error, one without the error are just regular MX.
Okay.
Should I go on to level 2? She messed up.
I throw one more at level 1.
One more for level 1. All right, let's see. Oh,
One more round for level 1. She's going for the double points.
One more round for level 1. All right. Did I do this one already?
When's your lab? Your AMP Monday, right?
My practicals on Monday.
Okay. Practicals Monday, lecture Wednesday.
Lecture is Wednesday, yes.
Okay.
All right, so this one here.
You got this, Johnny.
So that would be same linear.
Mm-hmm.
That would be just MX.
Mm-hmm.
And the angle is 180. Yes, no?
Yep. Sorry,
Oh.
I'm just mentioning.
I'm like, wait, was it too easy? And I messed it up? Like my SO2, Henderson?
All right. Now let's spin it up a notch. Let's make it more fun.
Okay, give me 2 seconds. Keep going. I'll be right back.
That
Let's
was
make it
MX
more
square. That was MX square.
fun. MX squared. Henderson, this is for you.
For 500 points.
Let me see. Okay. Oops.
Okay, I'm back.
AS5 F5.
AS
Mm-hmm.
F5.
F5.
1, 2.
And I said, Henderson, this is for you, so that's a clue.
Okay, I see. But that's AS. That's AS.
AS F5, yeah.
So we know that we are on the MX5. That's a trigonal by perimeter.
Just say bipyramid.
Okay, bipyramid with an angle of 90 and 120.
And
You want me to say like to draw it out?
no, the professor added one more. What was it?
Oh, 180, sorry.
Up 3, 90, 120,
90, 120,
180,
180.
and
Yeah, I said
180.
90, 120, and 180. Yeah.
Yep.
So on
I just don't think
MX5,
about the 180 because I already know that it's there. That's all.
so on MX5, he added an extra angle,
Yep.
right?
180. 180.
Only
Yep.
on MX5?
Only on MX5.
So it's
And what will be the
120,
MX?
180, and 90.
It'll be fine.
MX5. Yep. Damn, you would have been a millionaire that quick. You got the whole thing correct.
Yes, sir. Yeah, yes.
So is your like your value based on the electron, the valence?
The what?
Is your, like, it's MX5, so MX5 because you have 5, like 5 is your valence? Or that has nothing to do with it?
The 5 is basically telling you the geometric formula or shape. So because you know it's ending in 5, you know it's gonna be a bipyramid. If they tell you it's 6, you know it's gonna be octahedra. If you know it's 3, it's gonna tell you there's a tetrahedral. But if
Gotcha.
it gives you like if it tells you like a MX4E, now you know that that's a subclass of MX5 because if you put MX4 plus 1E, you know that's a 5.
Yes and no.
Yes and no. Yes. Okay. I know it's going to go to a molecular shape. Then that's where you have to start figuring stuff out.
It's MX5 is correct what he just said. Only
Uh-huh.
MX5 will just tell you its shape. That's it. But MX5. But to figure it out what it will not match the compound or the formula. This here will never match this. Because I showed you other examples where that would be an MX5 shape, but it's not an MX5.
Like a subclass.
That's because
when the
it's a sub.
subclass versions
That's
start
when they,
going.
okay.
All right, so another one. Quoting what's this guy's name? GJ Khaled. Another one. Ooh, this is a tricky one. I like this one. Give me this one.
CL2.
CL2.
So
I had to throw a tricky one in there. I just had to.
because it's an odd number. Wait, no. 14, 7 pairs. So CL. It's not linear?
It is.
Okay.
But what's the geometric shape?
The MXE.
E what?
Oh, is this the squared? MX.
If you did the structure, you will see it.
Yeah, MX squared.
MX squared.
Or MX2? I don't.
You're right, MXE. But what kind of
Mhm.
E? What number is the E?
E2.
No.
Oh no, I only have one E. So MX, I don't know.
Anderson?
What she said before? MXE2?
It was MX squared, she said.
No, and then I was like, wait, it's an
I just
MXE.
love that. I love that. MX squared.
You'll remember that forever.
I will remember forever that, yep.
Well, it's MXE, and you're saying E should have it should have a subclass?
It should have a number. It is a subclass, but what number is it?
So then one, because it's only one E.
Okay. Let's do it together. I was enjoying my food. All
You
right,
want to
so
break and eat?
no, I'm
You
fine. I'm just messing around. So how many values does
CLB
E have?
7.
7, right?
7.
7 times 2, and we get back to 7 pairs. CL,
Exactly.
CL.
Mm-hmm.
Oh yeah, I remember this one. This was a tricky one.
Connection.
1, 2, 3, 4,
3,
5,
4,
6,
5,
7.
6,
Mm-hmm.
7. And then you make a double bond.
Supposed to look like this.
Exactly. 3 for bond.
It's supposed to look like that. And it's supposed to take these guys here. This one's a tricky one to show. So let me show you how it look in a thing.
I didn't do it that way. I left it as it was initially with the 3 electrons around the outside of Cl, the middle
Mhm.
bond.
So
the
technically, you're
bond.
supposed to pick one side. It doesn't matter. Still, one of them is MX. And whoever you choose as M will have whatever 3 that's out in the outside. 1, 2, 3. 3. So in the plane, this is a this is a tetrahedral.
So the shape is linear, but the molecular geometry is tetrahedral.
Yep.
That's confusing.
What's confusing? The shape that I just drew? Not clear?
Not your drawing. Of course, you are an expert at drawing at this
No, I'm
point.
not. I'm not an expert.
You're an art major.
I'm not.
I'm just still that it's linear, but it's tetrahedral. So then does how is the angles 10 like if it's tetrahedral and linear, you have different angles on this? Is this like an exception to these?
This is a tetrahedral geometry, so the geometry is 190. The molecular shape is different.
109.
109.5.
Yeah, 109.5 is the geometric angle.
Okay.
It's linear when it prints out. When you write it out, see? It looks linear. See, that's how I get confused. Because it looks linear, but it's really that.
So where did you get E3 from? From the 3 surrounding?
You choose whatever you want to be X or to be M. And then whatever's left over around the M, that's how many electrons you count. There was 3 of them. So I choose this one as M, right? 1, 2, 3. And that will be my E3.
Okay.
Or just when you get like numbers like this. When you have 2 of the same, you have to make one M. Choose one.
So whatever M is around M is your E.
Mm-hmm. Whatever is around the M would be your E, yes.
Okay.
All right, let me give you this one. All right, you guys need more time?
No.
All right. So what would the structure or the shape and the geometry be?
I have
So
trigonal.
the geometric
Trigonal? Yeah. Trigonal what?
Planar.
No. Close. It looks like it.
Trigonal bipyramidal.
It's not by.
trigonal pyramid.
Trigonal pyramid. And what's the geometric shape?
109.5.
That's the
You said
bond.
shape? Sorry.
Yeah.
You said shape?
Yeah. You got the angle, right?
But I think I just gave you the shape. I said trigonal pyramid.
That's the shape. I'm in the geometry.
The tetrahedral.
Yep. And what's the MX?
What
MX.
is the MX?
Yep.
To solve it,
What's the MX? What is it? Which one is
the
it?
MX. Oh, to build it?
The
I
MX4.
mean,
What kind of MX is it?
4.
oh, what? Oh, okay. Yeah,
It's not 4.
yeah. MX3E.
Yep.
I wasn't understanding the question, sorry.
That's all right. Then I wasn't explaining it very well. Do you see it, Soljani? Because you're like, how is it this?
Yeah, the E's are throwing me off. I don't. So can you draw it out and see if mine is drawn out the same?
All right. Valence 5,
If we do the Lewis dot structure,
Three.
it's all you right there.
3. Then we have total 8 pairs.
Eight,
Divided by
divided by
2, you got
2, then you
4.
got 4,
So then N would be in
and
the middle.
Mm-hmm.
and then all three sides, and then you're left over by
H,
1.
H, H. 1,
Yes,
2, 3,
2,
4.
3, and then you're left over.
Oh, so I did the H above N.
Doesn't matter. Yours is just sideways.
No, I did H above, 1 to the left and 1 to the right.
So it's upside down.
Right, that's how I did it.
Yeah, yours is upside down. Technically, it's upside down.
Okay. So how did you why are
Let me
we
show
at
you.
E?
Let me show you that it's upside down. I'm going to extend this line here. Draw it over here.
Oh, okay. I know why I was, this is the sole, like this one's non-bonding, so that's why it's just E.
Mm-hmm. You got it.
Okay.
So the base would be here, and this part would be the top.
Okay.
The whole thing is a tetrahedral, but it's a trigonal pyramid.
How come in the book there's only, they don't have a trigonal pyramid? It's bipyramidal.
Yeah, that's the no, that's the molecule shape. The molecule shape is a trigonal pyramid. The geometric shape is a tetrahedral. The one we just did before had both the shape and the geometry was trigonal bipyramid because there's a pyramid on top and bottom.
Okay.
When it comes to the geometric shape, that's only a geometric shape.
Okay. When in my life am I ever going to need this? Like, why is this even a thing?
I don't know.
Right? Like,
Do you need to know the molecules of medicine?
when am I gonna need to know these shapes? Like, seriously.
It's useless information. In the end, it might help. You're gonna need it to share it to someone else. I'll be like, oh yeah, I remember I did this in college. All right. Let's do one of my favorites. Oh, they don't have much for that shape. Okay, so I guess I'm gonna do it. Give me the sky. It will give it away. I'm gonna rewrite that part. Yeah. SECL6. The number gives it away for this one.
It's gonna be an MX6.
Correct. It is going to be an MX6. And if it's an MX6, what shape is it?
Octahedral.
Exactly.
Yes.
Thanks.
Got it. And what would be the angles?
On octahedral, it's 90s, 90-degree angles,
And
180.
yep, that's what he put, 180 and 90. You were there when I showed them, right? Where they would be?
Yes.
Okay. Now, how would it look? How would you draw the structure?
SE in
Not
the
this.
middle.
What?
SE in the middle. SE equals 6. Like you want the math for the pairs and stuff?
No. I just want the whole 3D
The
image.
drawing.
The 3D image.
So SE would be in the middle, and then CL all around it. You need 6.
all around it. I mean, I can just draw it all around it, but it will look sloppy. Here's a trick that I always do with this. Try to see if I can make a straight line.
I can only see part of your screen. Why is that?
Hold on. Can you see what I'm drawing or no?
Yeah, now I can.
All right, what I try to do is I try to make a straight line going down, up and down. Okay. So far that's 2 down. Now I got to put the other 4. The other 4, I don't know if you can see it, but I try to make a T going this way or an X. So if I see the image that way, so I go, all right, a CL here, then another CL here. Same thing going across this way would be a CL here, another CL here. There you go. That's how that shape will be.
Okay.
So I started with the first line, going straight down, and then from there on, I see that's where my y-axis would be, going up and down. And then from there on, I try to see if I can draw a T in the middle. Anywhere you draw a T, you can draw it this way, you can draw the other way. It doesn't matter as long as you get a T. Once you put that T down, you can see where your x-axis will be all around. Or your base or your middle. And once you see your middle, and then you just all you do is just put everything around, and that's how you can do this.
Okay.
All right. All right, I'm gonna do one more, and then I'm gonna start chapter 5 because it's already 7.
Yes, sir.
Okie dokie then. This one should be interesting for you guys. Yes. Okay. I see it. Let's do this one. You ready? Don't be scared now. CH2O. Anderson.
I know I'm gonna have 6 pairs left. I know that.
So Johnny got disconnected, so she's hopping back.
Okay. I know I have 6 pairs left.
This is a tricky one.
I know it'll be C. C will be in the middle.
You want to go right now, Don?
Yeah, because I know H2 is a combined molecule.
All right. So you have how many pairs we have to put in together? 6?
6 pairs.
6 pairs. Okay. Okay. 6 pairs. C would be in the middle. Okay. What can go next to it?
Like this one. Yeah, it could go next to it. It'll be H and then no, it'll be yeah. H could go with carbon, but C cannot go with oxygen.
Yes,
So
we can.
oh yeah, because CO2, the H in the bottom.
All right. So let's do the first 3. 1,
1,
2,
2,
3.
3. And then
These
3
can't connect, so we
they
go.
can't exactly. It goes on the other side. The 3 remain the left. 1, 2, 3.
Yeah. And what
Pretty
does this
much
make?
it.
What does this make?
This will make a trigon. Trigonal. Thank you. My words are getting twisted up.
Triangle what?
uh, it'll make a seesaw.
Is it triangle what?
Connect this to.
I'm back.
Welcome back.
By pyramid?
No.
These are good. This is good. This is not.
It's only one sheet, only one triangle
The trigonal planar.
planar. You get just one triangle like that, it's just trigonal planar. And this is also called what? MX.
MX3.
MX3, yeah. Because the M is surrounded by 3. And if this was an electron, a non-bond electron, this would be what?
Then it would be MX3E1.
MX what?
Wait, what'd you say? If it's surrounded by?
If this is an electron,
It'd be a trigonal band.
it'd still be a
Trigonal
trigonal planar. Yeah,
That would be bent.
it will be bent.
And it would be MX2.
MX2
E.
E.
E. Yep, MX2E. And if you had 2, it would be what?
MX1E2.
MXE2.
Oh, you don't have to put the 1.
Nope. It's a trigonal, but it's mostly linear.
I'll jump back on. Okay, guys.
Okay.
All right, we're gonna start chapter 5.
Yes.
All right, starting chapter 5.
I'm gonna be on. I'm gonna be here, but I'm just not gonna be talking. But I'm gonna be listening.
All right. Chapter 5. You ready for chapter 5?
You sound so excited.
I need something to give me motivation to continue. So, chapter 5. I gave you guys the reviews so you can see with the formulas.
Yeah, let me print it real quick. I thought I printed it, but I didn't.
You're gonna need that. That's your answer key.
Guys, can you grab that from the printer? It's printing now.
So what I recommend for the geometry shape, just practice the shapes. If you want, I can give you some sheets that I have here that you can use to practice on, so you can get familiar how to draw the shapes. They're with the answers,
Okay.
with the dot structures and the shape, angles. Don't worry about the rest, the last parts, the polarity, whatever. That's what they're looking for, the polarity. Don't worry
He's
about that. He's just gonna ask you for the charge. So you just know how to do the charge, pretty much, which is valence minus
covalent bonds minus.
bonds minus non-bond electrons. Yes. That's the formal charge. All right, let's do guesses. We're doing guesses.
Wait, just a quick question. Like on his review sheet, he has like he's actually using dots, not lines. Those are representative of the electrons, or he,
Yes. He's using dots as the loose electrons.
okay. I'm like, all of a sudden he wants to start using dots now.
Mm-mm. So, but like I said, as long as you understand the concept on how to make it, whatever shape he gives, whatever formula or whatever thing molecule he gives you with a number, just do the dot structures, look at it, and then from there on, you'll figure out how to draw it. You will know what to draw. It just takes practice. You really got to practice the shapes.
Yeah.
So yeah, just use my geometric key to help you identify which shape it should be. Because one of them just gives you the whole chart with MX instead of saying MX, it's AX, but it's the same thing.
Okay.
And it just gives you everything with the angles. Where it says hybridization, ignore that. That's just talking about how the orbitals combine together.
Okay.
So don't ignore that part, but everything else follow it. Tells you about the bonded atoms, how many pairs you have by itself, the molecular shape, the geometry, how it looks in 2D picture, how you're supposed to draw in the Lewis structure. So that's a good chart to have, plus mine to give you the 3D version, how to see it in 3D. So you use those two together combined, you can, and just practice, you'll get it. I'll give you the worksheet so you can work it. It has the answers on it, so just, ignore the answers and just follow
Okay.
the letters that it gives you. All right.
Okay.
All right. So now that we're doing the gases, I put out the main thing on the sheet, which is just this. We got P, V, N, R, and T. These are the letters you got to remember. P stands for pressure. V, you know what V is, right?
Volume.
Volume.
I don't know why my screen is showing everything to the left, so I can only see half of what you're writing. It's so annoying.
Hold on. Can you see now?
It's not you. My computer, something's wrong with it. All right, I just minimized it and I could see it.
Okay. Do you see what N is? Do you know what N is?
Moles.
Moles, right? I'm gonna skip R for now. Do you know what T is? T is what?
Temperature.
Temperature. R is a special one. This one, it's called the gas constant. I wrote down on the sheet the universal gas constant formula to remember it. I'm gonna write it here in two, but not right now.
Is that
Gas.
the same constant he's gonna use?
It's the universal constant, so that's what I searched online. So it's the universal one. And what it shows in the book, I guess it's the same one. Because the book gives me this, the NRT. But remember, these are just, oh yeah, at the same time, these are, yeah, you guys need extra credit, so. Let me see, hold on, let me pull out the book.
I have the book. What do you want me to check?
The NRT.
Okay, hold on. Check.
What does it say about the constant? That's what I see in the book. That's what the R constant is. Yep. That's exactly what I wrote in the study sheet.
Yeah. 0.0821, yep. Okay.
All right, so I'm gonna write it there. I'm gonna write it here too. All right, so those are the four that you need to remember: pressure, volume, mole, gas constant, and temperature. The units for pressure is ATM, which means atmosphere.
Okay.
That's what ATM stands for. The measurements for volume is in liters, which is L. And you know the formula for, the unit for mole, right?
Grams per mole.
G mole. And temperature,
Kelvin?
it's in Kelvin. So it's K.
I know that thanks to Professor Tawani.
Thank you, Professor Tawani. You're the best. If you watch my videos. Kelvin. So yep, those are the units. ATM, L, Gmol, R is just R. Well, the unit for R is this. I have to put it in here. Zero 0.0821 times ATM times L over mole times K. Actually, better if I just do this in brackets. So that's the unit for R constant. 0.082 times ATM over mole times K. That's the unit for R constant.
So it's that, and then you're multiplying pressure times volume and dividing it by moles times temperature?
Yes.
Okay.
But don't forget, don't ignore how the unit is written. You're gonna see why.
Okay.
Because remember, he has a way of how he wants you to write it.
Because you have to cancel them out and
So that's the way I would like you to remember it. ATM times L, mole times K. And you see how everything cancels out. All this is needed for this guy called ideal gas laws. Because the formula for this, it's P times V equals N times R times T. So pressure times volume will equal mole times R constant times temperature. That's what that means.
Okay.
Is it all coming back now?
Yeah, from lab a little bit.
So before we get into this big monster guy, which is we're gonna call him our final boss, we have to introduce the first few formulas, which only involves these two. Pressure and volume. This one is called Boyle's law. I'm not gonna get into the history with this guy. Just know that he has a law. It's Boyle's law. His law is this formula. It's like the dilution formula.
P1, B1.
P1 equals P2 V2. So that's Boyle's law. So it's like dilution. So if they ask you for P, if they give you V1, P2, and V2, all you gotta do is, divide V here and divide V here, and you get, this cancels out, you get P1 equals P2 times V2 divided by V1. So I'm gonna keep this up here, and let's do one formula. One problem with this one. Ooh, I can copy this question. Yay, I'm not gonna type this whole thing. Please let me copy it. All right, I have a question for you. Here's a question problem.
She'll get a calculator. Hold, please. All right, I'm back.
Okay, so hold on. These questions want you to do extra conversion. I don't know if he's gonna be asking you that question. Asking you about extra conversions. What the hell? Where'd you go?
Me?
No, I'm looking for my paper. Okay. So there's two extra rules that we have to add, surprisingly. But I don't see him. I didn't see Professor Tawani said anything about that except for only this part. So there's an extra conversion. I gotta add that to the sheet. Damn it. Okay. It's converting mmGh to atmospheres.
Okay.
So I'm gonna do this one with you. So the rule for mmHg is this.
To ATM, right?
Yeah, to ATM. This is the rule. I'm going to type it here. You do mmHg divided by 760. And you get you get the ATM. That's the formula.
by 760.
Yep, divide that by 760.
So 0.984.
So what you did, you did 748
48.
divided by 760.
Mm-hmm.
You get 0.984. Let me see.
And 725 divided by 760. Zero 0.954.
Okay. All right. We're not doing it one step at a time. We have to do this all at once.
Oh, we're adding the MMHGs.
So we're adding a new unit to the whole equation. So just keep this in mind. Okay?
Mm-hmm.
Keep that in mind and keep this formula in mind. So how are we going to write this? So we're going to rewrite it like this. Give me the red. Actually, I'll make this smaller. I'm going to need a lot of space. P1, P1 equals P2, P2. Okay, that's our formula. Yeah, that's fine. I'm gonna write it here. So our P1, the pressure on this one is 748. mmHg. Okay, this size. 748 mmHg. Okay. Times our liter, which is 22.50. And that equals to 725 mmHg. And we don't know P2. Okay, this is annoying me so much. I'm gonna just write it up here. $748 HG with 22.5 L equals 725, and we don't know P2. Okay. All right, so according to this answer here, it looks like we don't have to do anything.
Don't have to convert, you mean?
Yeah, we don't have to convert from what I see in the answers. I see here, there's no conversion. But I'm just like a little confused.
He's supposed to be sending us problems, right?
I don't know.
He said that, but I haven't seen anything yet.
All right, so it looks like we're not converting anything. So I'm just gonna erase this part here too. So let's just go with what we have here then. So we know the rule P1 equals V1, P2 equals V2, following the dilution rule from what we learned. What do we gotta do?
So we have to multiply P1 and V1. Right?
No.
We're not multiplying P1 and V1. P1.
We have to get V2 by itself.
We're dividing.
Yep. And all of that. I'm writing all of that. And it will be on this side as well. MMGH, all that stuff. These two will cancel out and just be left with B2. And this is the formula that we're stuck with.
Right, but you're multiplying P1 and V1 and then
We can't
dividing.
do that yet unless this is on the other side.
Okay, all right.
Now we can do all that. Just plug that in the calculator and then your answer is there.
So 748 times.
Because these mg cancels out, all we're left with the liters.
So 23.21 liters.
748 times 22.5 divided by 725. 23.21. But we're dealing with 3 sig figs.
So 23.2.
3.2. Yep. Out. Want to try another problem?
Yeah.
Okay.
Can you hear me
So
now?
Yes.
All right, thank you.
Mhm.
I'm gonna do another problem. So we're gonna follow the same rule. There's no conversion here. Just go with what you see here. The names. There's other ways they write the atmospheres. So as we saw, MMHGH was one. They will also be calling it ATM, which is atmospheres, or TOR, TORR, torrents, or KPA, which is the same thing as pressure. So I'm also going to add on the review sheet to different units for pressure. Here's another one. A gas volume of 4 liters at a pressure of 205 kPa is, I think it's kilogram per pressure atmospheres. I'm guessing, is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant?
This time we're looking for P2.
Yeah, doesn't matter, P1, P2, V2, V1. So whatever you want to put for P1 or P2 doesn't matter. The formula still applies.
So I got 68.3.
Correct. 68.3 what? What's the unit?
ATM.
No. There's no ATM in this question.
What is the pressure in the container if the temperature remains constant?
What's the unit they're using on this one?
KPA?
KPA. .3 KPA.
Okay.
Because that's what the question is in. The last one was an MMGH, so but it didn't ask for MMGH, it asked for volume. So we wrote it in liters. You guys want to do another one?
Yeah, we could do one more. And then
Move
go
on
on.
to the next, then move on to the next law.
Yeah.
All right. I'm gonna give you, let me see. All right, I'm gonna give you this one. A 40-liter tank of ammonia has a pressure of 12.7 kPa. Calculate the volume of the ammonia if its pressure is changed to 8.4 kPa, while its temperature remains constant. Extra credit, here we come.
Word. .5 kPa.
Ow. Watch your claws. I keep telling you, watch your claws. Jesus. Hold on. You said 60.5 what?
Sorry. Okay,
60.5 kPa.
no, liters.
Liters.
Liters. They want his volume.
You put kPa, you would have got that question wrong. So there you go. That's P1V1, Boyle's law. Seems simple, right?
Yeah. Definitely give me my extra credit points.
All right. I'm gonna leave Boyle's law there. The next one, the next law we're gonna play with right now.
Are you raising your hand, Henderson?
Is he?
No, that was by mistake.
Oh,
The next law we're gonna work with is Charles' law or Charlie law. Okay, wish my computer would stop. Okay. Charles' law. And his formula is V1 divided by T1 equals V2 divided by T2. Yep. That's Charlie's law. And we know what T is, right?
temp.
Temperature.
Temperature. Right. So I'm gonna erase this. So I have here formula, a question with you for this one. Calculate the decrease in temperature when 60 liters at 20 Celsius is compressed to 40 liters. The answer is in Kelvin. So there's a conversion in this one. Temperature is in Kelvin, so you have to convert.
So we have to add 273.
Mm-hmm.
So do we do that? So V1 would be 6 liters. T1 would be 293.
Continue.
And then V2 would be V2 would be 4.
Okay.
And T2 is what we're trying to get.
Yep.
Okay, so V1 is 6 divided by 293 equals 4 over X.
439.5. Or 440.
Oh, wait.
366.
Wait. I think I did this wrong. remember the fraction? There's a fraction that's happening right now.
Remember what?
All right, I'm gonna write this again like how I was doing it. All right, so it's 66 liters divided by, well, the total was
93.
equals to, what we have here is 20, 4 over T, right?
For, yeah.
T2. So you see what's going on with this equal sign between two fractions?
You have to cross
You have to
multiply.
cross multiply.
Plus multiply, right? 6T. 4 times 293.
That's 1172. And then divide by 6.
And divide by 6.
So it'll be 195. Kelvin.
195. How many six figures we're working with?
It's only 3.
Mm-hmm.
So that's it.
Why you gave me 4? Okay, yeah, it's 195. Well, they gave me 195.3. But yeah, it's 195. But that's not how he wants you to write it, though. That's how you solve it. But that's not how he wants you to write it.
So we would have to write 6L for liters, 293K, 4L.
No, he wants you to write the whole thing at once. Like, what are you doing all at once? And this is what we're doing all at once. I will show you. Numerator here. Okay, so it's, we'll go, let me see here. Okay. 20 plus 273 K divided by 6.00.
Isn't it the reverse? Should be 6. It's V1 over T1.
Conversion to Kelvin. Then you're dividing it by 6. Then you multiply it by 4.
So we don't have to show the initial.
That's how
Like-
he wants you to write it. You want your extra credit? There you go. This is how you're supposed to write it. The liters cancels out. And you just left with the numbers. The K just follows all the way to the end. So if you plug it in a calculator, exactly how I read it here, you do parentheses, 20 plus 273, you close parentheses, divide 6, close parentheses, open a new parentheses, you write 4 times it, press enter, and you get this answer. And type it exactly like that, you get that answer.
What I was asking though is the formula is V1 over T1. So initially we don't have to write it as such because here we have to we have to cross multiply. But initially, the formula would have been 6 liters over 293 kelvins. Multiple equals 4 over X.
So you want to see it broken up the long way.
No. I'm just saying, does he have to see it that way?
Yes, that's how he was
That's
supposed to,
all the problems
all the tests
and
were.
what we've been doing. Yeah.
Okay.
That's how all the exams were written. That's exactly what he wants.
Okay.
That's what
And
he
now
kept
he's gonna take up points like he did on mine.
That's what he was stressing the whole semester. So you gotta learn how to use your
Yeah.
calculator. Put it in the calculator. It should be all
Okay.
easy at once. Did you put it in the calculator exactly how I showed you? Like that?
I do not know.
Do it. You'll see it. It actually you get the same answer. Exactly how I wrote it. Parentheses 20 plus 273. Close parentheses, divide 6, close parentheses, open new parentheses, 4, and close your parentheses. You write it exactly like that. You'll get your 195.
I did not get that, so I did something wrong.
Did you do the, okay, did you open it? Did you press open parentheses twice?
Yeah.
All right, do 20 plus 273. Don't enter, just 20 plus 273. Close the parentheses, just one, and then
Mhm.
press divide. Press
Mhm.
6, and then close the parentheses. And then open a new parentheses, because we're still going. 4, close down parentheses, and then press enter.
Okay.
Same number.
You
Got
got the
it.
same number, right?
Yep.
Yep, that's exactly what he means. If you put it like that in the calculator, you should get your easy answer. You shouldn't be stressing it, and blah, 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 and all that bullshit. I'm like, yeah, if you know how to do it first. If you teach us how to input it in the calculator, then yeah. If you don't teach us how to input it, then it won't work. So another problem with this. You ready?
I'm ready.
A gas occupies 900 milliliters at a temperature of 27 Celsius. What is the volume at 132 Celsius? Only one conversion, and it's just the temperature.
We don't have to convert milliliters to liters.
You can, but you're still gonna get the same answer. But I'm just telling you for this question specifically, there's no conversion, just the temperature. I'll be back. I'm getting some water. Let me know when y'all ready or need more time. No. Yeah. By the way, I got my test results back from my finals of nutrition and food science.
How'd you do?
I'm happy for my nutrition, for my science. It's okay. I'm gonna get an A regardless. But I was in shock that I got an 84 on my food science,
All right, but you got your A.
and I got a
Congrats.
90, and I got a 90 on my nutrition.
So another A.
Congratulations.
My exam, I got a 90. So I hope I get I hope I get an A.
Good job.
Thanks.
All right, let me see.
No respect. Wonderful. Do you guys need more time?
I'm trying to do it how you said in the calculator.
Well, what's your answer?
Mm. All right, so my V1 is 900 mLs.
Okay, hold on.
My P1 is 300.
100. So your T1 is 300, you said?
Mm-hmm.
300 what?
K.
Don't forget the units.
And then I
No.
have V2 is it's 405.
V2 is 405.
Sorry, V2 is X.
Mm-hmm.
and T2 is 405. Okay.
Mhm.
And then I converted the milliliters, so it's actually 0.9.
Okay.
So I need to get X by itself. So I'm going to, well, I cross multiply 405 times 9,
You did the cross multiply way. Okay.
which is 3645. And then 300 K. I mean, yeah. So divide that by 300. And it should be 12.15 liters.
Right, but the answer they want in milliliters.
Okay, that's why you said don't convert.
It would be the same way, but what would you just do? Convert it back to liters.
Multiply
Back to
by 1,000.
12.
So then it would be
12,150 mLs.
mm-hmm. So that's the answer. Cross
But the way
multiply
he
how?
wants it would be,
But that's not the way he wants it. Right. So he wants it
right,
this
that's what I'm saying. So the way he wants it would be
like this.
what?
Just keep it the way it is. 900 ml. Well, if you want to include the conversion, oh, gracias. If you want to include the conversion, then it will look like this. But I'm gonna do it without the conversion, and I'm gonna do it with the conversion. So this is without conversion.
So for Charles' law, it does not have the volume does not have to be in liters.
You mean Boyle's law?
No,
Oh,
we're
you mean
doing
no, Charles' law? Yeah. It does not have to be in liters. No.
in Boyle's law, it does.
Mm-hmm.
Okay, that's what was throwing me off. I thought we had to always convert it to liters.
So are you gonna? I'm gonna cover that in the end. That means I'm gonna have to re-edit that chapter 5 sheet.
I'm just, well, you can, I'm writing notes on it.
All right, that's fine. But that's why that's another reason why I wanted you guys to print it out, so you can add extra notes. All right, so I'm gonna continue here. So let me do. I just missed a step. Oh no. This is parentheses. The first one is 27 plus 273. Okay. 132 plus 273. We should get the same answer. So how to input this in the
zero.
calculator? How to input this in the calculator?
You're
Like
missing a
this.
0, but
I am
12150 mLs.
12150.
Mm-hmm.
It's supposed to be 1215. All right. So
You do
this is what you do in the calculator. Parentheses 900. Then you do divide. Then you open the parentheses again. 27 plus 273. Close parentheses and close parentheses. And you open a new parentheses, input that number 132 plus 273. Enter, and you get that answer.
Oh yeah, 1215.
And that's what he means. That's what he wants.
Okay.
So with the extra step with the conversion on the 900 milliliter, it would just be an extra step to punch in the calculator. It will look like this. Like that. And then in the end, this whole thing will be in brackets. It times it by 1000. So to input in the calculator was, like I said, it's an extra step to do this. You would type it in brackets, parentheses, 900, divide 1000, close parentheses, divide, open parentheses, 273 plus 27. You close that parentheses and you close that parentheses. Then you open a new parentheses, 132 plus 27. Close that parentheses, open a new, no, then you close that parentheses again. And then you open one more parentheses, 1000. And you should get that answer.
Okay. You can do the next law unless it's just you and I anyway. I think I'm comfortable with this.
It's so much my computer, my thing is like, what are you doing? My calculator couldn't process this, but yeah. That's how you're supposed to write it.
He
So it's
better
like,
not be that picky because he didn't even teach this to us.
He better not, but I don't know. I still wanna. I'm still trying to teach you how he would
No,
like.
no, no, I know, no, I get it.
All right, you want to move to the next law?
Yeah, I think I'm pretty comfortable with these four.
Okay, this guy is a homosexual. Wait, that's the wrong color. Here you go. Okay, what's his name? Gay Lussac. Gay Lussac's law. No jokes on it has nothing to do with making fun of homosexuals.
Disclaimer.
His law is similar to Charles, but he's going by P1 over T1 equal P2 over T2.
Is this the only other one we have to know?
Oh no, there's still one more. There's still more.
Oh, ideal gas law.
There's the ID gas law, and there's all of them combined.
What?
I love that response. What? So P1 over divided by T1 equals P2 over T2. Same thing. Now for this one, let me see here. It looks like
Give me 1 second.
the only conversion is the temperature. Mhm.
Okay, I'm back. Sorry.
Welcome back.
I
I'm
needed to
back.
touch.
I lost service.
Like, we've only been here since 4 p.m.
This is 4 p.m. It's nothing. You ready?
Yep.
All right. So for this guy's law, same thing like Charles' law. You know what that means? Only one conversion.
Okay.
That's only the temperature. Sorry that I'm starting off with this type of trick question, but you may never know. Okay, the gases in a hairspray can are at a temperature of 27 Celsius and a pressure of 300 pounds per square inches. If the gases in the can reach a pressure of 90 pounds per square inches, the can will explode. To what temperature must the gas be raised in order for the can to explode? Assume constant volume is 630 degrees Celsius.
So P1 is 30 pounds.
It can be P2. No matter. Just know
And
we're
then,
gonna.
well, I'm trying to make a chart like you always show us. So P1, 330 pounds. T1 is 27 degrees Celsius plus 273 to make it Kelvin.
Okay, so P1 is, you said
30 pounds per, I don't know what that
inches
IN2.
squared. Inches squared.
Okay.
Squared.
And then P2 would be 27 plus 273. So it would be 300.
P2 would be 300.
Sorry, I was doing T1. P2 is 90 pounds per inches squared.
And T1 is
300K. But why are they saying assume constant volume is 630 degrees?
to throw you off.
Oh, okay. So 300 Kelvin, and then we're looking for T2. So T2 is X.
See, it helps when you put it down, right?
Mm-hmm.
You didn't want to do that
When?
in the first in the first ones. Remember, you kept forgetting to do the charts because you always want to do it in your head. And I'm like, just put them down and you see what you're working with. Because you were struggling. Oh, what tool am I using? Oh, formula am I using? This and that.
Oh, back then for lab?
Yeah.
Yeah.
No, for his exams.
All right. All right, so I have okay, so we would do 30 LBS per inch squared. Divided by 300K equals 90 LBS inches squared over X. So how he wants it written would be parentheses 30 LBS per inches squared. Right?
I'm waiting
If-
for you to finish. And I'll tell you if
if-
it's right.
Divided by 300 kelvins. And then I like throw myself off when I'm trying to figure it out his way. I don't know why I just get all
I'm
confused.
sorry.
All
Sorry,
right.
guys. I'm losing service, and then I'm gonna continue watching the videos tonight and tomorrow when David posted, if I could see how you choose these walls. Okay, I understand that. I know you have to plug it in, but I'm just keep losing service in and out of it. So I'll watch the videos later.
All right, no
All
problem.
right,
Be
get
safe.
home safe.
All right. I'm not even home. I'm like all the way by Buffalo. That's why.
Yeah,
All right.
be
Thank you,
safe.
David. Thank you so much for your time.
All right,
And I'll
bring some
see you
souvenirs.
guys.
Bring like some acorns or something.
All
All
right,
right,
take care.
cool. I got you. See you guys.
All right, see you
Have a good night. Later.
later. All right, so there's a rule I want you to realize with this one. And first, let me do this, and then you'll see what the rule that I'm talking about. Let me write it in the fraction form. Oh God, my God, my table is clean. Stop doing that. $30 LBS. Okay, you know what? I'm not gonna write the units right now. I'm just gonna write that 30, 300. You know the units are there. Imagine they're there. Let's pretend they're there. 90, and we don't know, so we put T2. All right. So what I want you to realize is when we're solving for this, and they give you this, this flips. This flips. So it goes 300 to do it his way. 300 divided by 30, parentheses, 90. And that's how you get your answer.
So that's all I have to do for his way is flip it.
If they give you P2, you flip this and you just times it by that. If they give you the bottom, this stays the same, just times it by this.
Okay.
I'll give you another problem that requires to do the bottom one. I started with this one first because I want you to see it, because I wanted to introduce it.
So it'd be 900 Kelvin?
Mm-hmm. 900 Kelvin. Just don't forget to put the units in. But yeah, it's 900 Kelvin. And it makes sense because this is pounds. You know, the pounds per square inch, LBS. And this is also LBS. When it's,
So that cancels.
so they cancel, exactly. So all we left is with the K. And that carries all the way over here.
Okay.
I'm gonna do the same one, but I'm gonna do it now with the, when they give you T, we have to find for P. Neat questions, right?
Yeah, I was looking, I checked my email again because he definitely said he was sending us some questions.
Sadly, there's only 2 questions involving this law. Ain't much. But it's still the same concept.
I mean, the formulas thankfully are easy, so
Okay. That's not what I wanted to do.
I have a question though.
Go for it.
So how would you know what applies to which law?
Depending on the question they're asking you.
I know, like how?
You always do this. How do I know which is you have to read the question and the question will tell you what to do. Like this one right here. Let me just adjust it really quick. All right, now just let me adjust it and then we'll read it together and we'll see what to do. We'll see what they're looking for. All right, let's read the question. Maybelline Castell backup oxygen tank reads 900 mmHg. While on her boat, where the temperature is 27 Celsius. When she dives down to the bottom of an unexplored methane lake, why would you do that? Okay. On a recently discovered moon of Neptune, the temperature would drop down to negative 183 Celsius. Here's the question. What will the pressure in her backup tank be at that temperature? So they're giving us pressure. They're giving us Celsius. They're giving us temperature. And it's asking us for what will be the pressure on the way back up. It's not talking about volume, and it's not talking about anything else, just pressure and temperature.
Okay.
The question tells you.
All right, so I just have to remember.
What formula you're gonna need.
Yep.
So if the question is giving you, if they give you pressure and volume, then it's Boyle's law. If they're giving you volume and temperature, it's Charles' law. If they're giving you pressure and temperature, it's the Homo's law. I'm sorry. I'm sorry, but I'm trying to think of something you can remember. This guy,
I hope
Gabe.
nobody listens to this and gets offended. No, it's
I'm watching a YouTube Annie because of this. I'm like, I don't really care. But anyway, yeah, it's Gay-Lussac's law when it's talking about pressure and temperature. So let's work on this together. Let's make the chart.
so
P1,
P1,
T1, P2, T2. What's P1?
900 mmHg.
Okay.
T1 is 300 K.
You can read it already? Okay.
It's easy. P2 is unknown. And T2 is negative 183 plus 273. Negative 183 plus 273 equals negative 110.
No, it's not. Check your numbers again.
Oh, 90.
Yep. 90 Kelvin. So the next step, put it into that chart.
So P1 is 900 mmHg over 300 equals 90K.
All right. So remember the little rule I told you?
Mm-hmm.
If it's on the bottom, what do we do? What happens to this?
You reverse it?
Mm-mm.
Oh no, that one stays the same.
Stay the same. So then we will rewrite it like this.
Plus the units.
Plus the units, right? And what would the answer be?
270K. I mean 270 mmHg.
Yep. And that's it. That's how you write it. That's the
Okay.
answer there. This is how you show your work, apparently. And this is the first step you do.
Okay. These are pretty, as long as you do the chart and know, like, obviously know the formula, but make the chart, I think it's pretty easy.
Yeah, you need the chart, or else you would throw yourself off.
Yep.
All right, ready for the annoying part?
Ideals?
No.
What?
You think that's annoying? No. That's not that's actually the simplest thing. It's very simple because it's pretty much repetitive what we're doing. So
That
the
one,
last
pressure times volume equals nRT, you said?
it's pretty much the same thing, the same concept of how each law we just did, Boyle's law, Charles' law, and all that stuff. But before we touch that one, there's this one. It's called combined.
Oh, the one you said we got to use all these formulas?
All these formulas together.
What the hell?
This is P1
You didn't
times
write that on here.
P1.
Oh, yes, you did. Combined.
Divided by T2.
No, you have T1.
T1, sorry. T1 equals P2. I said equals.
P2 V2 over T2.
P2. Oh, God. There we go. That's the combined. It's just Boyle's law combined with Charles' law. Charles and Lucas' law. Yes, pull his ear, Lily. Pull his ear. My dog is pulling the other dog's ear. Like, shut up! Why are you barking?
Aw.
So yeah, that's pretty much what the combined law is. It's just Boyle's law combined with Charles and Gay's law together.
Gotcha.
Hold on. Let me calm the other one down.
Mm-hmm.
All right, I'm back.
Okay.
I have problems with this one too. I didn't leave this one out. It's a little bit longer. All right.
Mm-hmm.
So it's combined. So what does this tell you?
Hmm.
So if it's combined, this law is combined. So what is this going to tell you? What are you going to be doing?
Combining all the, what do you mean? I'm not
Okay.
sure what you're asking.
So for this one, what is the conversion?
Volume,
And for this one,
temperature.
well, these two, temperature, right?
Uh-huh.
So then if this one is volume and this one is temperature, that means
We're converting everything.
yes. As I told you, this is the most annoying one.
Yeah.
There's a lot of conversions, but thankfully this question,
Maybe he won't put this one on.
but thankfully this question here is only one conversion we need to do.
With this question?
The question I'm about to put right now.
Oh, I'm like, this question is the same as what we just did. Oh my gosh, my allergies are so bad.
Those allergies.
Nobody even put my tree on today. It's
I'll
terrible.
put it on. That's so mean.
I tell you, my sister got COVID.
No.
Mm-hmm.
It's because the temperature is getting cold. That's what it is.
She's a teacher. She's in
And
the setting.
well, not only that,
She's around a bunch of first graders.
but at the same time, it's still cold. COVID happens more in the cold than it is during the summertime. All right. So let's read the question. Let's see what it's giving us, and let's see what it's asking us. A gas balloon has a volume of 106 liters when the temperature is 45 Celsius and the pressure is 740 mmHg of mercury. What is the volume B at a temperature of 20 degrees and a pressure of 780 of mercury pressure? So it's like, oh, okay, you gave us so much numbers. What do we do?
P1.
So all we do is just type, the first thing we do is we have to put in what we have. Okay, you said P1.
I'm writing it. Hold on.
what I see is liters. So I see
So P1 is 740 mmHg.
P1 is 740.
V1 is 106 liters. And T1 is 45 plus 273. It's 318 kelvins. And then V2 is what we need. P2 is 780 mmHg. And T2 is 20 plus 273. That's 293 Kelvin. So we're multiplying P1 and V1 and then dividing it by T1?
Nope, we're not doing anything just yet. Well, let me write it out first here. Cool. All right, let me see how they have it here. Okay. So the rule is set 26 multiplied this by 318. And that equals, I'll put you all together in one thing. This equals, have 293. And 80. Okay. Mm, Okay. So technically we have to take this and move it on this side. But at the same time, it's a fraction. So to solve it, we do it like this. Remember the equal sign?
Mm-hmm.
Cross multiply. Okay, so let's do it.
So 318 times 780.
740 times 106 times 293. Jesus, that's a huge ass number.
Mm-hmm.
Okay. 2, 2, 9, 8, Okay, and that equals, you do 318 times 780.
248040.
The
Divided by 248040 on both sides.
mhm.
92.66 liters.
Um, $92, right? Hmm. What did you get?
Um, 92.658. So I said 92.66 or 92.7. Well, I guess they have 3 sig figs, so 92.7.
Have 4 bigs. 92.6566. Liters. But apparently, on the worksheet, it says that's not how how we get it.
No, that's not the value they're giving.
Mm.
What's their answer?
I'll show you. It's funny. It feels like his. It will be something like he would do. I'll show you. It's like I'll show you. I'll write out the answer that he wants. It's pretty much the answer that he wants. It's crazy on a worksheet just like that. So they have it written like this. Hold on. What temperature for T1?
T1 was 45 plus 273, no?
So okay, so you got
318?
oh, so he got his number wrong because you got 3151. I'm like, what is that? I don't see that anywhere. 315. Oh, so he got his temperature wrong. Okay, but it's the same way. So it'll be like that. 318. Okay. All this one together times this other fraction. Two, one, three. Okay. Right, that's what we got, yeah. 213. And then 780. Like that. So I guess we got the right answer. It was like 92.658 right here. 92.66. Oh, 658 to round it to 66. You put that in. Think you open parentheses, then you open another parentheses. 106. Close that. No, wait. Get it up. Times 740. Close that. Divide 318. Close that. We open the parentheses. Yes, into 2 and 3. Divide by 780. Close the parentheses and then you press enter. Yeah. So that's how you're supposed to write it.
Got it.
So it's following the same rule as we was doing over here, remember? So it's going to be flipped around every time. If it's looking for this on this side, if it's we have to flip it around. If it's looking, so if it's looking for V2, we flip the fraction.
If he was looking for V2, you said?
Yeah, if you're looking for V2, we flip it.
Gotcha.
You flip the V and T, and then you times it. All right. So let's see. I think we have another one that has the same thing. All right. So let's try another one. There you go. If 10 liters of oxygen at STP are heated to 512 Celsius, what will be the new volume of gas if the pressure is also increased to 1,520 mmHg of mercury?
So V1 is 10 liters. T1 is 512 plus 273.
Hold on. Trying to understand this question.
I think temperature is the same for T2. They're just changing P2 and then we have to get B2. Right?
So you're saying they changed only thing they changed P1.
Oh, wait. We're missing P1.
The thing is, yes, I'm saying, like, where did you get these numbers
We're
from?
missing V2 and P1? Or
You have
whatever.
10 liters. I think that's P1.
So we
10
have volume of V1. We have
volume of, yeah,
P1, which is 512 plus 273. But we
273.
don't have P1.
And we have P2. But where is T2?
Well, that's what I was saying. Is T2 the same?
Because here it says 785. Where did it get 785 from? It doesn't make sense. You know what? Okay, you know what? Let me use the last question. I'm gonna just change the numbers. And we should end up with the same answers together. That question, I don't know why it's like that. Okay. So I'm just gonna change the numbers around.
Okay.
There we go.
Okay. A gas
Can you,
balloon has a volume of 45 liters. So PV1 is 45.
yeah, me and you should have the same answers.
When the temperature is 20.
So what you got?
I'm almost done. Hold on. Wait, what did I just do here? Um, so you cross multiplied, right?
Nope. I did it all at once in the calculator.
All right, so I don't know what I just did. I did 1,000. It's 1052 times 45, right?
Mm-hmm.
Divided by 293.
Mm-hmm.
Divided by 293. And that's 161. Okay. And then $700 divided by 253.
700 divided by what?
700 divided by 253.
Upside down.
253. Mm, what did I mess up here? Oh, I reversed it.
But with
It
the
was
unit.
253 divided by 700.
Mm-hmm.
Okay.
Plus the units. So what would you answer yet?
So then that was 253 divided by 700 multiplied by 1 point was 58.39.
Correct? Yep, that's what I got.
Okay. Okay, and we still have one more law.
Mm-hmm.
Dios mío. All right, you said this one was easier. Ideal gas law.
Mm-hmm. Wait, do you want to do another problem with combined or?
No. My eyes are starting to shut.
All right, let's do the last one in there. It's a lovely, lovely, lovely.
Oh my gosh.
And this one is PV, P times V
Mhm.
equals N R. All for the extra credit. All for the extra credit.
Seriously.
All right. I have problems with this one. I'm already prepared. I
What'd you say?
have problems for this already. It's for us to do. All right. So a rule that I need to put over here. R, is this always equals?
2, 1.
So this is always given. So whatever he gives you for R, that's what it is.
Okay.
It's always given.
We have
If
to
I have,
convert moles? No.
not right now, but you might have to.
Oh my God.
Frankly, this one's given. If I have 4 moles of gas at a pressure of 5.6 atm and a volume of 12 liters, what is the temperature? Let's use this formula.
So it's 5.6 multiplied by
Make your
12
chart.
liters.
Make your chart. Make your chart.
So we have P is 5.6 ATM.
Okay.
B is 12 liters. N is 4.
R
R
is
is
given.
0.0821. And T is unknown. It would be 5.6 ATMs multiplied by 12 liters. equals 4 times 0.0821 times x.
Wait. This also has to be included. And the x. So that's how it's supposed to be written. The thing is, what the hell do we do here?
What to get t?
Yes, like so. We're just left with t. Everything crosses out. ATM with ATM. L with L. This mole with this mole. And the K will go to the end. And just input these numbers.
Mm-hmm. I got 204.63
Yep.
Kelvin. That was right?
Yep. So you see it's kind of repeating.
Mm-hmm.
It's just using, it just gets fatter and fatter. But it's the same thing over and over again. It's just that it's fatter and fatter. See, single, one at a time. Well, group, single, single. Then they start getting fatter and fatter, and there you go. Let me put this here, and then do that there, and then do that. There you go.
Okay. I think I can do that. We can try one more.
You want to do one more? I thought you were tired.
Yeah, but I'll do one more just to make sure
All
I
right.
get it. I'm just tired of sitting in this chair already. I'm like, I did like a whole work day right now.
You sure you don't want to end it right now?
It's up to you. I can do one more unless you're over it as well.
I can keep going.
All right,
Sure.
we'll do one more. One more and that's it.
I'm showing no mercy, that's why.
I want the points, so
I'm trying to see if we can have a little toughy one. All right, I'm just gonna go with this one. Okay. If I have an unknown quantity of gas at a pressure of 1.2 atm, volume of 31 liters, and a temperature of 87 Celsius, how many moles of gas do I have?
OPVN RT R 0.0821. Pressure is 1.2 atm. Volume is 31 liters. And temperature is 87 plus 273. So it's P 1.2 times 31 equal N Did I do this right? So it's 1.2 times 31
Or let's see how you write it. Let's see what you did. You did what now?
1.2. Shit, hold on. 1.2 times 31 equals N parentheses N times 0.0821 times 360.
Okay.
And then under the each divide by N times 0.0821 times 360.
What you got?
Hold on. 1.2. $1.26 moles.
Mm,
No?
yeah, but it's just around. They didn't want it to round.
Oh,
But you got it right. 1.2586.
okay.
There you go. You're
All right.
good.
I'll keep practicing problems, but I just got to make sure I memorize the formulas.
I can give you the worksheets. I'll send them to you through WhatsApp right now.
Okay.
I'll send you everything. I send you everything over.
Okay. And I'll send you your stuff in the, by the morning
I
for
need
A.
I need somebody to help me with practical.
I can